mean every atom makes one free electron in copper. Okay, one atom corresponds to one electron. If 1.1 ampere current is flowing in the wire of copper whose diameter is 1 millimeter, so radius is half into 10 raised to minus 3. Then drift velocity Vd is how much? Approximately will be how much if density of copper is 9 into 10 raised to 3 and atomic weight is given 63. Density is mass upon volume. Hello?
Yes, sir.
This is given atomic weight. So mass is 63, volume we don't know, density is 9 into 10 raised to 3. Therefore volume is 9 into 763, 7 upon 10 raised to 3. What is current formula? N A drift velocity into electron. So drift velocity is I upon N A E. So I upon N means number of electrons per unit volume into area is pi r square into E. I into volume V is N into pi r square into E. I is 1.1, volume is 7 upon 10 raised to 3. Number of atom is Avogadro number because atomic weight given. So it is 6.023 into 10 raised to 26 because we have taken this in kg. If you would have taken gram, then it was 10 raised to 23. This is in kg, so 10 raised to 26. This many atom will come. Pi is 22 by 7. Into r square, which is 1 upon 2 into 10 raised to minus 3 square into charge of electron 1.6 into 10 raised to minus 9. See, till this for me it is important. Rest all is substitution. Just come till this, then I am explaining that substitution का simplification. Number of electron is number of atom. Number of atom in atomic weight is Avogadro number. Even in electrostatic, one place we did this. First, till that concept you have followed, why n small n became n upon v, and n is 6.023 into 10 raised to 26. Anybody who has not followed why Ni took Avogadro number?
Followed, sir.
Okay, dear. इसका बाद I'm solving 1.1 into 7 upon 10 raised to 3. 6.023 10 raised to 26 into 22 by 7. So 7 will go up. उसके बाद 1/2 का square means 1/4. 4 will go up. Into 1 because it is square, so 1/4, 4 will go up into 10 raised to minus 6 into 1.6 into 10 raised to minus 9. By the way, can you tell me what will be the answer closest to 0.1 millimeter? Na? Drift velocity is in the order of 10 raised to minus 4 millimeter per second. Correct? Na? Drift velocity is 10 raised to minus 4 meter. So answer should come 0.1 millimeter. So we'll see whether it will come or not. This is 7 into 7, 49 into 4, 11 into 10 raised to minus 1 upon. 10 raised to 3, 10 raised to 26.
Sir,
10 raised, yes.
are you writing something?
You can't see.
No, sir. Your cursor is stopped.
Stop.
Your cursor is not moving.
Who is saying this is what moving only na?
Sir,
No,
no.
sir, we
Can't
can't
see.
see.
No, sir.
No.
10 raised to 26, 10 raised to 23, 10 raised to 29. These people are coming in between. What these people they are doing? So much disturbance. Now it is okay.
Yes, sir.
So in between, then they disturb us. So that's why sometimes it creates a problem. Ten raised to 29. This is 22. One 22. 1.6 10 raised to minus 25. 11 twos are 22. 4 into 0.4. So we get 49 upon 0.8 into 10 raised to minus 25 and 29 will be minus 4. Minus 4 goes up 10 raised to 29 and minus 25 will become plus 4. Plus 4 goes up minus 5. So this is now 49 into 8 into 10 raised to minus 6. 49, 10 raised to minus 1, 10 raised to minus 4. 1 minute, I'm putting all the values again. Formula is same, just I'm putting the values. Drift velocity equals to, what is current I? How much is current I? 1.1?
Yes, sir.
1.1. Current is 1.1. N is number of atom. How much? 6.023 into 10 raised to 26. Correct?
Yes, sir.
And volume will come up. How much we got volume?
7/10⁻³
7 upon 10 raised to 3 we got. Density is mass upon volume. 7 upon 10 raised to 3. Correct?
Yes, sir.
Whatever you are telling, that only I am writing. If you are telling wrong, it will become wrong there. 7 upon 10 raised to 3. And then what it was further? 5r square, I think. Further it was 5 upon 5r square.
Yes, sir.
Yes, sir.
ये 7 नीचे ही था. बराबर है क्या ऊपर था कुछ क्या ऐसे ही है? How much is R? One upon 2 into 10 raised to minus 3 मतलब minus 6. इतनी है अभी. Any more term? Yes, any more term? Charge of electron. No? 1.6 into 10 raised to minus 9. I think these are the only terms.
Yes, sir.
The 7 will get cancelled. 4 into 0.4. So this will become 1.1. That is 11 into 10 raised to minus 1 upon 6.023 into 10 raised into this 22. Equal 10 raised to 3 into 26 and minus 6 is 20 into 4 into 10 raised to minus 20 minus 19 minus 24 minus 6 minus 26 will be 20, so this will get cancelled. Now we got 10 raised to 3 goes up, 11 into 2. So drift velocity equals to 8. 4 into 2 is 8. 8 into 6, 48. 4 goes up, 63 up. 6 into 2 into 4, 8. 8 into 6, 48. So let me make this about number. Just read the sum. All of you read the sum. One of you read the sum. Yes.
Every atom makes one free electron in copper. If 1.1 ampere current is flowing in the wire of copper, having one
1.1 ampere current. Then
1.1 ampere of current is flowing in the wire of copper having 1 mm diameter, then the drift velocity
1 mm diameter means area is 5 into R is half millimeter, 10 raised to minus 3 square into 1.6 into 10 raised to minus 9. Number of atoms present per unit volume. Volume is not known.
Volume is density, mass upon density, right?
6.26. Now volume wala part please. What is volume? Can I say? Mass upon density. How much is mass given?
63 kg.
63. And density?
9 into 10 raised to 3.
6.023 into 22 by 7 into that 9 into 10 raised to 26 minus 25. 10 raised to 1 into 22 by 7 over here. 1 by 4 ka 4 will go up into 1.6. Okay. Hello? Hello?
Yes, sir.
Substitution clear?
Yes, sir.
So now this 9 into 763, 11 into 2, whatever. So 7 will go up. This is 2 into 2, 4. 49 into 2 in numerator. 6.023 into 10 raised to 1 and 3 is 10 raised to 4 into 1.6. See, 16 6 are 96, correct?
Yes, sir.
So this is 98. This is 9.6, which will be close to 9.8 only. This is 16 into 6, 96. So I'm writing 9.8 into 10 raised to 4. That is 98 upon 98 into 10 raised to minus 1 and 10 raised to 3. This gets cancelled. So 10 raised to minus 3. 10 raised to minus 4 आना चाहिए. एक 10 किधर गया? 10 1 4 minus 19. 1.1 का 10 raised to 1 दिया नहीं. हो गया. हेलो? इसका 1.1 था ना, इसका 10 raised to minus 1 आएगा. So minus 1 हो गया आंसर. 10 raised to minus 1. 10 raised to
Minus
minus 4 meter. It is 10 raised to minus 1 millimeter, 0.1. Some substitution error we were making. But important is remembering concept, not the substitution. I too was knowing formula value. You are also knowing 0.1. So directly also you can mark sometime. Just remember, atomic weight contains Avogadro number. If it is in kilogram, then 10 raised to 26. If in gram, then 10 raised to 23. 53 you asked. Okay. Complete आराम से करेंगे because बहुत कम डाउट होएगा आपका इसमें. After 53, with some
74.
directly 74.
So 57.
हाँ वही बोलो डायरेक्ट कैसे चले गए 57 तो अलग टाइप है 57
So 57.
yeah 5700 before this also you want something
No, sir.
voltage current characteristics for non-ohmic device is given V is 4 times I square ना 4 times I square then what is the resistance when current is 1 ampere See, whenever it is curved, then resistance at any point is slope at that time. Slope means dV upon di. So dV upon di, can I say it is 8I?
Yes, sir.
अभी तो हो गया. This is resistance R.
I
When
is 1.
I equals to 1, then R will be dV upon di, that is R, is nothing but 8 into 1. 8. 8 is the answer.
Yes, sir.
After this, directly now 74. Yes, just check properly. Directly 74.
Yes, sir.
Okay.
Yes, sir.
74 is assertion and reason. Current is passed through metallic wire so that it becomes red hot. When cold water is poured on half of its portion, metallic wire, rest of half portion becomes more hot. Resistance decreases due to decrease in temperature. So one is assertion they have given, and we have to check whether reason is perfect or not, or if both are wrong. 74th we are doing. When cold wire is poured, cold water is poured, definitely temperature will fall.
Yes, sir.
Due to this, resistance will decrease throughout. Correct?
Yes.
If resistance decreases, what about current? It will increase or decrease?
Increase.
Current will increase. What is heat ka formula in terms of current?
I square RT.
I square RT. तो करंट बहुत ज्यादा होएगा, स्क्वायर में बढ़ेगा. So दोनों करेक्ट है ना. It becomes more hot because I increases in square. So assertion is correct. Hot के ऊपर cold water डाला, resistance कम हो गया, current ज्यादा हो गया due to decrease in both are correct. Means A is the option. Both assertion and reason are true, and reason is correct explanation. Resistance is decreasing due to decreasing temperature. Beautiful sound. After this, very few you might have doubt. After this, are the assertion,
83.
assertion reason 88 भी नहीं है. 53 again assertion and reason. A pure semiconductor has negative temperature coefficient of resistance. What is temperature coefficient of resistance? Alpha is increase in temperature resistance upon original into rise in temperature. Since semiconductor, when temperature increases, then resistance decreases. That means it passes current at high temperature. So it has negative temperature coefficient बराबर. मतलब जब भी टेम्परेचर बढ़ता है तो उसका अल्फा कम होता है. कैसा लगेगा? Can I say RT is R0 1 plus alpha delta T? This is formula.
Yes, sir.
So if alpha is negative, then this will become 1 minus. So RT will decrease now if alpha is negative.
Yes.
R0 plus alpha R0 delta T. तो 0 डिग्री पे रेजिस्टेंस ज्यादा, हायर में कम, तो ये नेगेटिव होना चाहिए. तो अल्फा नेगेटिव है उसका. ओके, फिर से समझ लो वापस.
Yes.
फिर से समझो. Resistance at higher temperature for metal, we got 1 plus alpha into change in temperature. Correct or not?
Yes.
In case of semiconductor, when temperature increases, resistance decreases. What does it mean? I should have resistance at higher temperature R naught minus of R naught alpha delta T. That means alpha is minus, resistance cannot be minus. Okay, follow meaning?
Yes.
So when temperature is increasing, resistance also increases, alpha is positive. When temperature increases, resistance decreases, alpha is negative. Semiconductor behaves like this. So what they are telling is correct. When you raise the temperature, see now sometimes it may be difficult because semiconductor एक full chapter है पढ़ना है. On raising temperature, more charge carriers are released. So conductance increases and resistance decreases. अभी मतलब क्या है इसका? Semiconductor are those substance which has 4 valence electron with neighboring atom. मतलब हर एक एटम के पास 4 इलेक्ट्रॉन. They share them with covalent bond. लेकिन जब हीट करेंगे तो बॉन्डिंग ब्रेक होता है ना. बॉन्डिंग ब्रेक हुआ तो ज्यादा फ्री चार्जेस मिलेगा, करेक्ट?
Yes, sir.
Yes.
And hence they can conduct. If they conduct, means resistance is decreasing. So A option, both are true and reason is also correct explanation. Then somebody said 88 again. 88? Yes, 88.
Yes, sir.
Yes, sir.
Yes.
Resistance of wire at 20 degree is 20 ohm. At 500 degree, it is 60 ohm. At what temperature the resistance will be 25 ohm is the question. With the help of these two, you have to find alpha. So I know RT is R0 1 plus alpha T. R20 upon R500, R0 will get cancelled. 1 plus alpha into 20 upon 1 plus alpha into 5. T कितना 500. अभी ये 20 ohm and this is 60 ohm is 1 plus 20 alpha 1 plus 500. 20 into. So by cross multiplying 1 plus 500 alpha is 3 plus 60 alpha. 500 minus 60 will become 440 alpha equals to 3 minus 1. So alpha is 2 upon 440, 220. 1 upon 220 per degree Celsius is alpha. This much you all follow?
Yes, sir.
Just copy to this. Now again I am taking two equations so that R0 will be cancelled. That means R20 upon RT I am taking. So R20 upon RT, R0 will get cancelled. 1 plus alpha into 20 upon 1 plus alpha into T, which we have to calculate. R20 is 20 and RT is 25 equals to 1 plus 20 into alpha 220, 1 plus alpha, which is 1 upon 220 into T, we have to calculate. This is 5 into 4, 5 into 5. So 4 plus 4 into 1 upon 220T is 5 plus 5 into 20, 100 into 1 upon 220. This is 4 upon 220 is 5 minus 4 plus this 100 upon 220. 0 you can cancel, 2 into 11, 8, 5. 4 into 520, 4 into 520. So 3 upon 55 is 1 plus 5 upon 11. LCM. So 3 upon 55 is 11 plus 5 upon 11. 11 into 5. 3 upon 5 is 16. Therefore, T equals to 16 into 5, 8. Answer. I think you might have made mistake in R0 वाला part. Correct? ना?
Yes.
फर्स्ट टू वैल्यू से अल्फा निकालना है, अल्फा मिल गया तो एक नोन और एक अननोन से टी निकालना। Once you have completed, tell them it's up. After this, switch some more. Hello, after this.
$93.
So tomorrow, please keep your book ready because I will put off on the video. एक एक का book check करने में. Really, you are doing homework या खाली ऐसी randomly doubt पूछते हैं? Let your book be ready. I am going to correct your book tomorrow. Homework book, especially. So as per that homework given, I want to check your homework. When a current is passed through a conductor, okay, 5-degree rise in temperature is observed. If the strength in conductor is made 3 times, then rising temperature will be how much? Current is made 3 times through that conductor, then rise in temperature will be how much? Very good sum, beautiful sum one who has asked. Can you tell me what is formula for heat in terms of current?
Yeah.
करंट का टर्म्स में हीट का फॉर्मूला
Square R.
I square R, correct?
Yes, sir.
Okay. Or V square upon R. But we are interested in terms of current because current के बारे में बोला है. Can you tell heat formula in terms of temperature? Mass into specific heat into rising temperature.
Yes, sir.
Yes.
So one formula is I square RP. That means this H is proportional to I square. Equation 1. Here mass is same, specific heat same, so H is proportional to rise in temperature. So can I say I square is proportional to rise in temperature? Correct? Huh? So I1 square upon R2 square is rise in temperature in first case. Second case, current is I1. बाद में triple किया वो लोग ने 3I. How much is first change in temperature?
5
5.
degrees.
5. Second we want I1 cancel. 1 by 9 is 5 upon delta theta 2. Therefore delta theta 2 is 45 degrees Celsius. Beautiful. हीट का दो फॉर्मूला है, एक करंट में, दूसरा इन मास एंड चेंज इन टेंपरेचर. राइट. ब्यूटीफुल समझ लो. Completed 93.
Yes.
After 93, which one?
95. 95.
This is also better. Good sum. Two cities are 150 kilometer apart. Two cities are 150 kilometer apart. Electric power is to be sent from one city to another through copper wire. The fall of potential per kilometer is 8 volt. So potential per kilometer is 8 volt. That means 8 volt per kilometer is potential. And average resistance per kilometer is 0.5. What is power loss? What is formula for power in terms of potential and resistance?
V square
V
by
square
V
by
R.
square
R.
upon.
So if I find total potential for 150 kilometer and total resistance for 150 kilometer, my problem is what?
Yes, sir.
Potential, if I find for 150 kilometer and resistance for 150, my problem is solved. Huh?
Yes, sir.
Yes,
So,
sir.
so can I say total potential is equals to 8 into 150? Correct, na? And total resistance is 0.5 into 150. I hope you followed. नहीं समझा? Potential per kilometer is 8. So 8 into kilometer, total kilometer will give you this answer.
Yes, sir.
Same way total resistance. नहीं समझा? Per kilometer means per unit length given ना. So potential per unit length given 8. 8 into length is total potential. Same way resistance per unit length is 0.5 into 150 is total. Now V square means 8 into 150, 8 into 150. Purposely I did multiplied squared because I know that R के साथ cancel हो जाएगा ना एक का. 0.5 into 150 ये cancel. 8 into 8 is 64. into 150. 0.5 is half. This will go up. So therefore it is 64 into 2 into 150. 128 into 150. 15 into 8 is 120, carry 12. 15 into 2 is 30 and 12 is 42, carry 4. 15 and 4, 19. This much watt. So it will become, after 3-digit I am putting decimal, kilowatt. Okay, 19.2 kilowatt. Any doubt?
No, sir. But
That concept we followed, the potential for 1 kilometer given, we found for 150. Resistance for 1 kilometer given, we found for 1. After this,
So 97.
97, 87 or 97?
Yes. 97.
97.
See, I think in your batch I told, देखो पावर कम हो गया तो डिम हो गया था, याद है लास्ट लेक्चर बताया था
Sure.
बहुत। तो इधर बोला
हाँ,
रेशियो
yes.
ऑफ ब्राइटनेस मतलब रेशियो ऑफ पावर चाहिए ना आपको।
Yes, sir.
Two bulb operating on standard voltage of 110 has resistance 9/60. What is power formula? V square by R or not?
Yes.
So, brightness means you have to find always power का ratio. So voltage is same, will get cancelled. R2 by R1.
16:9.
So R2 by R1 16/9. This is the option. अच्छा sir.
So, sir, whenever brightness or anything related to
Whether
that
they
is
say
when we use
yeah,
power.
power is whether it is dim or bright, it depends upon power. Power कम dim हो जाएगा, power ज़्यादा bright.
Okay, sir.
देखो कॉमन मिस्टेक हमेशा हम लोग वोल्टेज को सोचते हैं पावर का, वो खाली पैरेलल में होता है, लेकिन जनरल यही है, पावर कम तो ब्राइटनेस कम, पावर ज्यादा ब्राइटनेस ज्यादा। आफ्टर दिस $98, $99, $100, इसमें है कुछ डाउट?
No, sir.
Till 100 there is no doubt now.
No, sir.
No, sir.
Okay. You all have completed till 100 or more than that?
130.
150.
110.
I had given how much in that sheet?
150.
150 तक दिया है, तो और 50 किया रहेगा आपने फिर। अच्छा आज रात को कर, आज रात को करेंगे लगता है।
Yes, sir.
ठीक है, कोई बात नहीं, 100 पे will stop. So today we stop here till 100 you have done, because exam में आपको 1 से 200 के बीच में से है 45. So please complete 150 तक today, so that morning I will discuss 150 तक का डाउट, and फिर 200 के लिए एक दिन और ले लूंगा, खत्म हो जाएगा। 300 के ऊपर समय तो भी require devotion of time. उसके बाद कम कम समय बाकी चैप्टर्स. So today we'll